So we'll start the third lecture now. So today we'll talk about version control systems. That's going to be the major discussion topic for today. In addition, to demonstrate Git, which is the version control system that we'll discuss today, I'll be talking about Python, which is the language that we'll be discussing first in the first few lectures to discuss some scientific computing algorithm implementations. And in that process, when we are writing the Python code, I'll also demonstrate to you some Git commands that we'll be using, because this is an applied skill. So why not do something, some actual scientific computing, and then use Git in a way that we'll be doing realistically when working on a project. By the way, a note. So yesterday's lecture, there were a couple of problems with some solutions towards the end, which I did not discuss yesterday. So please feel free to have a look at those slides. So they are in continuation of what we discussed. So if you understood what we discussed in the class, then you should be able to understand those problems. So they'll help you practice. Do try them yourself first, and then you can have a look at the solution. So today, as I said, we'll be talking about Git, which is the version control system that is widely used these days. And then we'll also talk about GitHub and Bitbucket, because most of the projects that you see and you work with are uploaded on one of these repository management systems. Okay, so we'll explore some standard projects and see these online tools, which are quite versatile. You can do a lot or extract a lot of information from these online tools on the projects. For the Python demo, I'll be using a problem of computing square roots using the Newton's method. Okay, this is a numerical algorithm that is used for calculating square roots. And this is just an example to demonstrate scientific computing. And we'll again be doing this later when we start using Fortran and high performance computing. Then we may pick it up again in the future. So it is also important now onwards that you understand the algorithm. Okay, that's as much, because if you don't understand the algorithm, then implementing that would not be, it's difficult to understand, and that won't be fun as well. Right, so version control system was originally developed to deal with large software projects, but nowadays, and not just nowadays, but it has also been used by single users. So as I gave an example that while doing my PhD, I was using version control system to keep a track of the history of my thesis. Okay, so when I'm writing a thesis, it's a big document. So to keep a track of the history, I was using this version control system. So that gave me an option to revert to previous versions if needed. And I mean, of course, with large codes, if you're working collaboratively, that helps a lot, because then one person's changes, I mean, multiple people can work on the same code at different sections, and then when they are interested, they can pull the changes made by the others into their own version of the code. Right. Another useful thing that we can do with the version control is that you can work on multiple machines. So for example, I'm developing a software, and mostly I work from the office, but sometimes I get amazing ideas while at home, and I would want to implement them there away. So what I can do is I can work in the office, I can commit the changes, and the changes they go onto the repository, let's say GitHub, and then when I am back home, and I have yesterday's version of the code on my laptop, I can pull the changes from GitHub. So then I get the latest version of the code, I make some changes and push it back to GitHub before going to the office. And then so you don't need to keep a track of laptops or hard drives to have the latest version. So this allows you to work on multiple devices. It's the same way that you use, I mean, nowadays people use cloud a lot. For example, you use Google Slides to prepare slides when you're working collaboratively, or you don't want to depend on a particular device while developing your presentations or documents. So this is a similar thing, except that it also keeps a track of the versions, and it also can deal with files of different types. Right. So the earlier approach to version control was the server client model. In this case, as the name suggests, you have a server which has one official copy of the code. Okay, and the server will have all the history of your project. But the client, which is, let's say, my laptop, for example, what I will do is, before I start working, I'll check out a working copy. Okay. So I'll get one version, which is the latest version, and then I'll make changes to that version, and then once I am done, I'm happy with it, I'll check that in back to the repository, which is sitting on the server. And then the server will give a new version, and then if somebody wants to update their copy, so they have to get it back from the server and so on. So I mean, it still does not keep multiple copies in a way that whenever you put in a new version, a new commit, that does not mean that it will have a copy again, because that will make it very large. It stores something called a change set. So if you made one change, you made change to just one line in the whole code, which was 1 million lines in total, including all the files. There's no point storing all the files again. So it only stores information about one line that has changed. So that's called change set. Okay. So when you commit it, it will have that information that this line has been changed from this to this. So that ways only the changes get saved. So overall the storage space remains quite in control. So what are the characteristics? As I said, that the latest version has to be checked out. Checkout is like, you check out a book from the library. So you have to check out the latest version from the server. You have to make changes, and then you check that back in or commit it. So commit and checking that back in mean the same thing. But if your server dies for some reason, then all the history of the project goes with it, because your computer does not store the history of the project. So if there were, like, let's say 1000 commits the project by different people at different times, all that information was only available at the server. So the server has to maintain multiple copies or backups, otherwise everything gets lost. Okay. And as I said, you can only commit an update to the server, because the server has all the details of all the copies, but you can still maintain multiple branches of the code. So there is, in server client model, there used to be one trunk, like a trunk of a tree, and then there were different branches. So what that means is, let's say you have a code, for instance, that does finite element modeling of mechanical systems. Then somebody would want to start a new project where they want to implement multi-phase flows using that finite element system. So that multi-phase flows version, which is built over the finite element system, will be one branch of that code. And then somebody in parallel somewhere else in the world is working on some solid mechanics design. So they will have a different branch that they are working on. So they may branch away quite far away. So you can have multiple branches which are using the same major chunk of the code. But in future, when people are happy that yes, this branch has reached maturity, so then they can, those changes can be pulled back into the trunk. So then the main version of the code will have these features available as a standard version. Okay. So this is how multiple people can work on the code as different branches. So we'll be using this idea of branch in our Git practice as well. So let's talk about another approach which is being used nowadays. It's called distributed version control. So the earlier one, as I showed here, was server client model, and this is called a distributed version control. So this is more modern, and this is what is being used nowadays. So the difference between server client and distributed is that, as the name suggests, distributed, that the complete history of the project is available to everyone. So if you clone the repository, like you will be doing today as a practice, you will have the complete history. Everybody who will clone it will have the complete history of the project. So if the server dies, no issues. If you are working on you have multiple copies of that project at different places, they'll all have the same history, as long as you're in sync with the project on the internet. So if, for example, I make a change on my laptop, I can keep committing changes. So I can have different versions being developed without having internet. Okay, I don't need to check that back in onto the I don't need to push the changes onto the repository. I can keep putting commits on my laptop, and once I push the changes to the repository will have all the commits that I did on my laptop. It's not that whenever I check that back in, the changes between checkout and check-in are the only changes there. I can maintain different versions at different times on my laptop and then push all that information at one go. Now this will start making more sense when we start doing things. When I'm saying this, it might be a bit confusing to you, but as I said, this is the hands-on course, so we'll be doing this in the class, and it will be much clearer then. So I'll tell you about this .git subdirectory that is there, which has basically, it's a hidden file, as we discussed yesterday. Dot files are hidden files. So we don't want to mess with it because it has all the information about all the change sets, all the commit history of the project. So if you make some changes to it, then it really messes up the repository. You may have to start from scratch again. Right. So how do we clone repositories? Because mostly we'll be cloning somebody else's repository. In fact, we did that yesterday. We cloned a repository from Software Carpentry website to practice our bash commands. So what we do is we use the git clone command. So git space clone, and then you put in the repository URL, which is an HTTPS link or an SSH link, and then you have, if you want optionally, you can have a name. If you don't put a name here, then by default it will have HPSC underscore 2023, whatever is the repository's name will be the folder name that it gets cloned into. But if you want to have a different name, you can still do it. Right. So Git is one. I mean, there's another one called Mercurial, but Git is more or less become a standard now, and most of the developers and people who work with repositories will tend to use Git nowadays. So typically we'll work with certain commands that that should be discussed before we even start using them. So one command is called git commit. So if you make a change, if you make a new file, let's say, and you would want to now commit that to the repository, so you'll use a git commit command. So I'll say git commit with a message saying that I have created a new file, which is then this is version 0 of the file, commit. So that is gone. So this is basically, that's a version frozen in time. And now if I make some changes and I see that, okay, this is a decent enough change, then I can again do a git commit minus m, which is a message that this is the version 1 where I have added these features to the file. So that ways, you yourself can see the history of the file, how it was developed. And if multiple people are working together on a file, it really helps to understand what change was done at what time. There's another command called git push. Git commit, what it does is it creates a version, but that version is not sent to the internet on the repository management systems such as GitHub or Bitbucket. It is still there on your machine. Now if you want to send the information back to the internet, then you have to use git push. So what it does is it will push everything, all the change sets that were done between the time you cloned the repository and now that you're doing it, whatever commits that you had done between those two times are sent to the internet. So now that is available on the server. So anybody else who would want to clone it now afresh, they will get this complete version. Okay, so git commit creates versions and it will keep them on your local machine, and push will simply send all the commits to the internet. So push will not create commits. Commits are important. You have to create commits first and only then you push them. Now let's say we are working together collaboratively on a project and I make some changes and now you would want to pull them. So I send you a Slack message that I have added these features to the code. Why don't you have pull them and then merge with your version of the code that you're working on, and let's see how it functions. So then what you would do is you would do a git pull. So what you would do is you will fetch the changes and then you will merge them with your working copy. So let's say we are working on the same file. So you are working on one function, I am working on another function, but they are still part of the same file. So it's a two-step process where you fetch the changes and then you merge them, but there is a command called git pull which does fetch and merge together. So Git is very smart in that sense. I don't even use fetch and merge these days. I tend to use pull, and Git is very smart. It tries to figure out if the changes are at places which are quite far apart in the file, then it will not even bother you with anything. But if we are making changes to the same line of the code, then it does not know which one to keep. So then it will give you an error, or it will give you an option to choose which line you would want to keep. So it's quite explanatory in that sense, the errors that you will get. But that rarely happens if you're working collaboratively on a project. We will not want to touch the same parts of the code. Right. So what are the advantages of distributed model over the server client model? One is that everybody has the complete history of the project. So if I have if there were 1,000 commits to the project, I want to check out an earlier version of the project. I don't need to connect to the server. I can just check out the version that I want on my local repository, and I don't affect anybody else's work while working on my clone. So this allows me to commit a lot while debugging. So let's say I'm debugging some feature. I clone the project into one folder on my computer. I am debugging something, so I keep committing multiple versions, but I will not necessarily push them onto the server. It's just for my and when I'm happy with the final version, I'll pull another copy of the project in a separate folder and put those changes and then push them, so that I don't need to push the 100 commits that I did over the 1 week while I was debugging the project. But I do need to do those 100 commits because while debugging, you put in a feature, try it, and then see what happens. Then you try another feature. So rather than maintaining 100 copies of the file saying that feature 1, feature 2, feature 3, you keep trying different things and then you override them. But before that, you just commit and say that I tried, this is the version that tries feature 1, and then you run it. Then you change the code version 2 that tries feature 2, but all those versions are there available in your local machine. In fact, you can even push that to a new repository that you create on your GitHub account, so that that information of sequential commits that you are doing while debugging is available on the internet. There are memes for software engineers that if there is a fire, then what you do is you do git commit, git push, and then you run. Okay, because you don't want the working software features to be lost. And whoever has lost information because of some hard drive failure or some kind of that issue, that's very frustrating because you have to write that stuff again, and it's very boring as well. Right, so let's start with the demo. So what I'll do now is I will demonstrate to you a repository management system called Bitbucket, which allows you to maintain repositories. So we'll open some reference repo, and so you don't need to do anything right now. You can just follow me while I'm doing things, and then once we start writing the code, then I'll give you time after every few minutes to try things yourselves and do them, because I don't have commands available today. So let's see how the demo works, but we'll go slow while writing things while doing lab. But right now I'm just demonstrating something to you, so you can just have a look. Right, so let's open Bitbucket. So this is the Bitbucket website where repositories are managed. So I'll have to look for a repository. So let's see if there's a search feature here. Well, Google's good enough. So let's look for a repository which is the one I mentioned, that we are closely following a course by Randy Lewick, which is taught at University of Washington. Right. So this is the repository. So you'll see that it will have bitbucket.org as the URL, and then it has the username, which was RJ Lewick. For you, it will be your username, and then it has the repository name, which is UW-HPSC. That was University of Washington, HPSC, High Performance Scientific Computing. Right. So this is this is how the repository looks. So this is the first page that you see. So you'll see the code here is so for those sitting at the very end, can you still see this projector clearly? Okay. Good. So this is the code that we have. So we have certain folders and some files, and then you'll see that there's some text available here. So this is your README file. It's always good to have a README file for a project that you're putting up for others, because you'll want to explain something. So that README is a markup file that you can have here, and you can even see this file which is a part of the project. And then you have some files here. So let's say there is a folder called codes. In the codes you will have something called Python, and then you will have script1.py. So if I click this, I can see the code. So this is the latest version of the code. Okay. It should show me the right. So this is where I see the commit. Somebody had created a commit, and during that commit this file was modified. So now I am looking at the complete commit, where all the files, including this file that I was looking at, was committed. So it shows me the file, for example, lab 15 and this file. This was a Python notebook. It tells there's a minus with a red color, so that this was the line deleted and this was the line added. So modification is deleting and adding a line. So for example, here this pylab inline was modified to from pylab import star. So you can easily see that what changes were made. So it's very intuitive to quickly browse through what changes were made on different files. So you can actually look at all the commits. It shows you the complete history with details. So this has a date, what was the message during the commit, who committed that, so multiple people can work on the project, and there is also a commit number which is called the hash code, which uniquely identifies the commit on Bitbucket. All right. Any questions till this point? Right. So let's go back to source. You can see there's a clone button here. So if you click that, then it gives me a URL. In fact, the whole command. So I can simply press this and it copies this to the clipboard. So I can simply paste it on the terminal and press enter, and this will clone the whole project. So can you either use HTTP or SSH depending on which protocol you want to use for cloning. And it also gives you some options to use graphical based Git management systems to do that on your machine. But we in this course we will be using text based systems, because as we discussed, it's always good to have an understanding of the text based commands, so that then you know what features are available, and then GUI graphical user interfaces will tend to use these commands in the background, so you can understand them easily yourself. Now here we see that there are two branches, one is called master, one is called Coursera. So this course was also taught at Coursera, so there is a Coursera branch as well. Okay, so this, I mean, you can select whichever branch you want, and you can see this is a different version because it has only 4 folders, and the content could also be different. So we can maintain different branches in the repository. Right. So let's go to commits. Let's have a look at some commit. So for looking at a commit, we have to click on the hash code for the commit. So there is an option called side by side. So rather than looking at the diff or the difference in the same file, we can look at side by side. So this shows me the right hand side is the newer version, left hand side is the old version. So I can see how the lines were modified. So this is an option to view the entire file. So if I want to look at the entire file, because here it's only showing me the changes, the code snippet where the changes were done, only the lines where the changes around the point where the changes were done, but I can look at the whole code by viewing the entire file. Then there is an option to open in source. So what that does is it actually opens the latest version of the file, and Bitbucket will also try to format the file depending on the type of file you have. So this is an RST file, so it formats it to do some sort of a formatting where you have italicizes something, put some URLs and so on. So this is if you have a Python notebook, it will try to open in a notebook format. So you can do that as well if you want to look at not just the source code but also the sort of version of file which is formatted. You can hide the comments if there are some comments in the code to understand only the code parts and so on. Let's so we can also look at the raw commit. So if you do that, then it actually gives you the text. So this is typically what you would see if you are trying to do this on a terminal. So this is the actual information, and that Bitbucket graphical interface that you are seeing is actually interpreting this to show you something in a nice way. So here you have the complete hash code. Okay, so this is a 40-digit hexadecimal string which is uniquely identifying. So there is some sort of algorithm that Git uses to create this hash code. So it has information about who did the commit, when was it done, what was the commit message, what were the changes that were done, and so on. Okay. Any questions? Why not discuss that when we actually start doing things? Okay. So you can think of branches as you can have multiple branches of the code, and each branch can have different files modified in a different way. They can actually become very different from each other. I mean, usually you would not do that, otherwise you will have different repositories, but you can work independently between the branches, and then you can actually move files from one branch to the other. That is also possible. But ultimately the goal is that if you are working on a branch and then you are happy with the version now, so you would typically pull that back into the main branch, and that becomes a newer version of the code. Think about it. I mean, if you are adding a new feature to Linux, so Linux, I'll demonstrate the Linux repository to you soon because it's open source. So you will work on a branch to implement a new feature, and once you are happy, once that has reached a stage, it's been tested properly, it will be pulled back into the main or the master branch, so that it is available to everyone. Okay. So here we have the different branches available. So you can see there's an option called pull request. So this is what I was saying, that if you are working on different branches and you are happy, you will want your version to be pulled into the actual branch. So here this person was working on a fork. So this different person has the same branch but on a different ID. So they made some changes and they asked It's called a pull request. You request the manager of the repository to pull your change into their branch, and they would then review it. So there's an automated process sometimes, and if they're happy, then it'll import those features. So when multiple people work together on a given software, they'll tend to do that. Rather than messaging or calling, they'll use this automated system so that things are quite robust in nature. So here you can see what are the requests declined, if there were any merged, or all the, so whatever requests were already merged are visible here, and so on. And you can select which branch you want to discuss, look at. So you can look at different branches and their pull requests and so on. Let's talk about issues. Sometimes, let's say you are working, you are not even developing the software, but you realize that there is an issue. So you can log into your Git account and you can raise an issue. You can open an issue. Okay, and then you can mention what is how urgent is the issue, what kind of an issue you have. Is it a bug in the software or something else? And then what is the priority? And then you can even assign it to someone if you know who will be managing it or who can then figure it out too, so on. So that ways you can create issues, and then people can take it up and they can work on them and so on. And then when it is done, they will mention that this issue has been resolved. Okay. That's pretty. There's a lot more, but I don't want to spend too much time here. You can explore these things yourself over the next few months when you work with the repositories. And then if you want to download the whole repository, there's an option to download where you click it and it will download it as a zip file. If you want to keep it because sometimes Git is not installed on the machine. You can't clone using a git clone command. So you can download the repository as a zip file and keep it with you. Okay. Any questions?
Work on it and make changes, then when we push it back, where will it go first?
It will go to Bitbucket. So if you cloned it from Bitbucket, so you do a git clone and then you have this whole path, right? So let me go back to this option of clone. So there is this whole path. So it will go there. So if you clone my repository and you try to push it back, it will give you an error because you will not have access to push onto my repository. So typically in that situation, you would fork it, and that fork will go onto your ID, and then you will pull it or you will clone it from there. These things will start making sense when I give you assignments to work on. Okay, so these words like forking and then cloning and then pushing, but when you push it, it pushes back to the same link that you cloned it from. But you can manually set it. So we'll do it today when we set a new repository, a fresh repository. We will manually set the origin of the repository where we'll push it, because we will start from scratch, right? So there is we did not clone it from anywhere. It's a new repository. So we have to give a path ourselves. So we'll do that, and you will understand how to manually change. In fact, you can have different origins. So I can have 3 different places on the internet, and I can push it depending on where I want to send. So I can have origin 1, origin 2, origin 3. Origin 1 could be Bitbucket, some ID. Origin 2 could be some other ID on Bitbucket. Origin 3 could be GitHub. So I can send it anywhere.
Like in case I don't have access to pull it back, then what should I do? Like
push it back. Push it. If you don't have access to push it, then you create your own repository and push it there on your ID. Because you would want to maintain a copy. That's your concern, right? So if you're making some changes to the repository you cloned, although the repository was mine, but you still want to ensure that those changes are backed up on the internet. So for that, you would create a repository on your GitHub account, and then you will push it there. Or best is you fork it. So when you fork it from your ID, it will create a copy of that repository on your ID. So whatever you do there is yours. It's not going to be. In fact, when I showed you this pull request, so you saw that this JHAN shoe, so this Coursera branch on the repository, so this was a fork of the repository. So this person created a fork of the repository, worked on that, made some changes, kept pushing it, and then finally when they want to merge it, you don't even have to push it to that repository, because your GitHub ID has a repository which is a fork of the original one, which has some new changes. You simply send a pull request from there. So I mean, this is Bitbucket, but it can also happen on GitHub. So they will, from one repo to the other, it will synchronize. This will start making more sense when we do things. Okay. These are very many new terms, and software engineers tend to have these terms which will usually not make sense to normal people. So you'll start these will start making sense soon. Right. Next, I would want to discuss GitHub. So let's do that. Let's close this. So for GitHub, I will discuss with you about a repository which is called Linux. That's the actual Linux project by Linus Torvalds. By the way, Linus Torvalds is the one who developed Linux. So Linus is his name, and Linux comes from merging his name Linus with Unix. So that becomes Linux. Okay, so if you Google GitHub Torvalds Linux, so it will give you the GitHub page for the Linux page that is maintained by Linus Torvalds. So this is the Linux that you see these days, and it's quite active. You can see the last commit was done 12 hours ago. So this person who developed Linux long ago is still working on it and maintaining Linux these days. Okay. GitHub seems to be a bit more popular for maintaining large repositories. Earlier, GitHub could only do public repositories, privates were not possible. So you could, whatever you create is available to everyone. But now GitHub has given the feature to create private repositories which are not visible to the others. So now GitHub and Bitbucket are interchangeable in that nature. But still, GitHub is used for large projects, and Bitbucket is typically used for small ones. But we'll be using GitHub because it's more popular nowadays. Very similar features. Looks a bit more intuitive because it's being used more, so managed well. So you can see that there's a code. So you can see the whole code of Linux. There's a README. That is this readme.md file. Then if I click on, let's say, some version. So let's go to this recent commit. So it automatically gives me the commit that was done 12 hours ago, the recent one. So I click it, because some people who are actively following a code will just want to see what changes were done very recently. So it shows that 14 lines were modified. In fact, and it also tells you how many new lines were added and how much modification, how much deletion was done. So this is some sort of an indicator that it's mostly new addition. If it is a lot of red here and very small green, then that means that most of the things were deleted. Okay, so you can see easily, it's very similar. You can also have a split view, like a side-by-side view. So you can do that as well. So again, very similar to what Bitbucket did. So now I have already logged into GitHub with my account. So it is giving me an option to comment on the commit. So I can leave a comment. Okay. So this comment will send to Linus Torvalds on his GitHub account from my ID. So if I feel that there is some problem with this or the ID needs to be modified, I'll quickly send a comment, and that again preview it and then comment it. So that comment is visible, since it's a public repository, it's visible to everyone. I can subscribe to it so that it sends me notifications if changes are done to the repository. Let's look at browse files. So then if I do browse files, it will show me all the files, the complete code for that commit. So now if I go to a previous commit, so let's say I go to all the commits. Yeah, so this is, it says there have been a total of 1 million commits to this project. So these many times the project has been modified. So now you can see the complete, these are the branches. So I can see all the branches available here. So we are looking at the master branch. So here I can see all the commits. So I can click any commit, let's say this one, and then it shows me the details of the commit, and I can go to the browse files option. So this will give me the snapshot of the project, all the files as of that commit. So if I go to a commit 1 year ago, so it will give me the snapshot that was 1 year ago. And we learn how to check out those versions, old versions, in case we realize that the old version was what we wanted, not the new one. Right? Any questions? So there's some information here, some statistics that there have been 52,000 forks. This is what I was saying. Forking is something that you can do to create a copy of this project on your ID and then do whatever you want. How many people are watching? You can simply just watch it by clicking the watch button. So this will sort of give you some notification when changes are done. You can like it. If you like it, you put a star to it, and so on. So a lot of options available here. Pull requests. So people who have made changes and they have asked Linus to pull their changes into the main Linux project. These can be seen here. The actions, well, this is not important for now. And then there are some analytics available here in terms of insights. So you can have a look at these analytics. Who are the major contributors to the project and so on. By the way, for software jobs, it's always recommended that you maintain a GitHub repository, create projects, do some contribution to other open source codes and so on, so that as you grow your GitHub, if you have never created a GitHub account, do that now and maintain it nicely. Don't just randomly put stuff there, because if you want to stay in software, people will ask you for your GitHub. And because see, you cannot go in past and put information on GitHub. So if you gradually put information on GitHub, then that stays there. So if an employer looks at your GitHub account and they see changes, you have been contributing to different projects over the last 2 or 3 or 5 years, then they can see that yes, you did not create an account yesterday and put information there. You have been actively contributing to projects, open source projects, over the last many years. Okay. So it's a very useful place to be. Right. Any questions before we move on to the actual demo now?
Pool is to open to all.
Sorry?
Such pool is to open to all for the all codes.
Pull? Yeah, so pull means if you are pulling information that is being modified by somebody else, right? So yeah, I mean, if it's public, some people will start with a public repository, but they'll later change the settings to private. So then if you try to pull it, it will not be able to pull that. So that depends on the owner. So as an owner, I can change for example, I can actually show you my ID. So if I go to my ID, okay, so I have 6 repositories, and here for example, this is HPSC 2023. If I click it here, so this was last year's repo, so I can go to settings, and there's an option to change the visibility. So I can change the visibility from, right now it's public, I can make it private. So then you cannot pull it, even though you cloned it today, but if I change it tomorrow to private, then you cannot pull the new changes, or you cannot, this will not work if you try to interact with the repository again. But I can do it because I will be logging through my ID. So even it's private, I can still work on it because it's managed by me. And you can create collaborators, multiple people can work on private repositories and so on. Right. So let's right. So let's continue. I just have a couple of slides, and then we can actually go on to the Python and Git demo. We'll have a break first. Okay. So GitHub I have discussed, this repository. There are many other projects also, very popular one in fact, IPython, Jupyter Notebook, NumPy, SciPy, Matplotlib, all these projects are open source projects available on GitHub. Okay. So it's worth exploring them if you tend to use them. It's worth exploring what sort of work goes into maintaining these on a daily basis, because new features, they interact with other libraries and so on. So it's not just one person's work. Many people work together to maintain this, and that is the reason Python is picking up very fast as compared to any other commercial software, because commercial software will only be modified by those who are employed in the company, but open source codes are managed by many people, and because of these features where you have multiple moderators for a given code and so on, so quality is maintained, and in case something goes wrong, you can always revert to a previous version. There are also graphical user interface based tools available. So one of them is called GitK. I'll demonstrate that to you when we start the virtual machine after the first part of the lecture today. So then I'll show you how to install it on the virtual machine yourself. By the way, this is a very simple tool, GitK. It's actually available from Git. This simply allows you to look at the changes. It does not allow you to make changes and so on. And but there are other tools available. Some of them are free, some of them are paid, which can allow you to do many things graphically. But again, we will tend to work on the terminal because that gives us full control over the commands available. And by the way, Bitbucket and Git also allow you to make changes to the files their way. You don't need to clone it, make changes on the computer and then push it. You can actually make changes on the internet only. So that is also possible. It was not available earlier, but some years ago they included those features because many people nowadays work on software and they make minor changes and they would not want to maintain the hassle of cloning it, making changes, pushing it and so on. Ignore that. So let's have a break now and then we'll meet up again in 5 minutes and then we'll start with the demo.